Hey everyone, and welcome back. Today we're going to pull back the curtain on something that's literally powering almost every container you've ever used. But you might not even know its name. It's the real unsung hero of the cloud-native world, and we're about to dive into what makes it so important.
So you know Docker, right? Of course you do. You probably use it all the time. But have you ever stopped to think about what's really doing the work when you type Docker run? The answer might actually surprise you.
The truth is, for years now, the core engine has been a completely independent project. It's this incredibly robust, lightweight, and seriously powerful piece of tech called Containerd, and it's been the industry standard all along, just hiding right there under the hood. All right, so let's get into it. What exactly is this engine that's driving the whole container revolution?
Okay, so what is Containerd? At its heart, it's the core runtime. It handles all the nitty-gritty stuff. Pulling images, storing them, actually starting and stopping the containers, managing the networking, the whole lifecycle. Think of it like a minimalist, super efficient car engine that bigger tools like Docker and Kubernetes just plug into.
And its journey is pretty fascinating. See, Container didn't just appear out of nowhere. It actually started its life as a part of Docker. But then in 2017, something huge happened. It was donated to the CNCF. Yeah, the same foundation that manages Kubernetes. And by 2019, it hit graduated status. Now that's a big deal. It's like the CNCF giving it a gold star, telling everyone, hey, this thing is rock solid and ready for the big leagues, right alongside giants like Kubernetes and Prometheus.
So we know where it came from. Now let's pop the hood and see what makes it tick. What's the core philosophy behind Containerd?
The folks who designed Containerd were really focused. They knew exactly what they wanted. First, performance. It had to be super lightweight with almost no overhead. Second, stability. This thing was built for production, so it had to be rock solid. It also had to play nice with everyone else, so it strictly follows the Open Container Initiative or OCI standards. And finally, it had to be extensible, built with a plugin system so you can add your own features. This laser focus is really its superpower.
And this slide right here, this perfectly shows you where Containerd fits in the whole stack. So way up at the top, you've got your orchestrator, something like Kubernetes, barking out the orders. It talks directly to Containerd, which acts like the manager, right? It gets the request and organizes everything. Then, Containerd turns around and tells a lower-level tool called runc to actually do the work, to execute the container. And runc does that by talking to the Linux kernel. So you see, Containerd is that absolutely critical middleman, translating high-level commands into low-level action.
Okay, that makes sense, but how does it all work? Let's trace a request from start to finish and see what's really happening under the covers. It all kicks off when something like the Kubernetes kubelet sends a request to the Containerd API. The main Containerd daemon gets that request, pulls the image if it has to, and then it does something really smart. It spins up a tiny, separate process for that container called a shim, and it's this shim that then calls runc to do the final execution. The analogy I love is this. Kubernetes is the driver turning the key, Containerd is the engine managing the whole startup sequence, and runc is like the pistons that actually fire and get the car moving. And this little shim process, it's kind of the secret sauce. It's the magic trick. Because every single container gets its own shim, it means the main Containerd daemon can be restarted, maybe for an update or something, without killing all your running containers. I mean, that is a huge deal for reliability. In the old days, if the main daemon crashed, poof, everything it was managing went with it. The shim totally changes that game.
And that focus on reliability and simplicity brings us right to Container's biggest job today, being the default #1 go-to runtime for Kubernetes.
Just look at the difference here. On the left, you've got the old way. Kubernetes had to talk to this thing called the Docker shim, which then talked to the Docker daemon, which then finally talked to Containerd. It was this long, complicated chain with an extra hop. Now look at the right. The modern way is so much cleaner. Kubernetes just talks straight to Containerd using a standard API called the CRI. It's direct, it's streamlined, and it's way more efficient.
And this wasn't just some optional change. In Kubernetes version 1.24, they officially ripped out that old Docker shim integration. It was gone. And that move basically cemented Containerd's place as the standard for any modern Kubernetes cluster.
So, why should you care? What's the big deal? Well, a simpler stack is a faster stack. Simple as that. You have less overhead. It's also way more reliable, right?
Fewer moving parts means fewer things can break. And it's more secure because the attack surface is just smaller. For anyone running Kubernetes in production, this was a massive win all around.
Okay, so its role in Kubernetes is crystal clear. But let's zoom back out a little. How does containers stack up against some of the other tools you might have heard of?
This table really lays it all out. You've got tools like Docker and Podman, which are fantastic all-in-one developer tools. They have everything you need. But Containered and its cousin CRI-O are different beasts entirely. They're designed to be minimalist, super lightweight runtimes. They're not for you to interact with directly. They're built to be the engine inside a bigger system, like Kubernetes. Their job is to be that boring, stable, core runtime that just works.
And this old Unix philosophy quote just nails it. Do one thing and do it well. That is Containered in a nutshell. It's not trying to be your developer toolkit. It has one single job. Run containers as efficiently and reliably as possible. And it is exceptionally good at that one job. Its real power is in its focus.
So here's the thing. Containerd is the quiet, invisible engine that powers the cloud today. But the world of containers is always changing, right? We're starting to see containers that are actually tiny VMs or serverless functions or even WebAssembly modules. So that leaves us with this really interesting question to chew on. As the definition of container keeps evolving, what will the engine of the future need to be? What comes next? Pretty cool stuff to think about.